Welcome to my channel. If you have worked with remote sensing, then you must have gone through the hard times where you need to download multiple datasets to get what you want for your region and your required date. But Google Earth Engine saves your time and storage of your local computer by giving access to multiple satellite imageries without even downloading them. Sounds great. So, today we will get familiar to this Google Earth Engine. We will search for some datasets. We will work with image and image collection, clip them to our region of interest, filter them by the date of our choice, and also visualize in the map and export as TIFF format. Let's start. This is the link with which you can open the Google Earth Engine Code Editor, a browser-based coding environment for processing and visualizing satellite imagery. Before you can fully use Earth Engine, especially for uploading, saving assets or running tasks, you need a cloud project. You can either create your own project or be added to someone else's project. This project actually stores your assets and controls permission. You will search for the datasets from the search option here. In the central panel here, we will be writing our Java script for processing and visualizing our layers. On the scripts, there are many examples shared by collaborators. You can reuse them for similar workflow. The Docs tab here is like a built-in API manual where you can find a list of different functions grouped by type. You can click on the function to see their usage and examples. Earth Engine has a lot of functions and remembering every argument is nearly impossible. So you can always have this tab as a quick reference whenever you are lost. Whatever data you upload in your GEE are listed under the Assets tab. Assets are stored inside our cloud project. In the Inspector tool, you can see the pixel value of the map, whereas immediate results are shown under this Console tab. Whereas in the Task tab, long-running computations are shown. And this is the map where your added layers are visible. You can adjust the visibility once you have added your map from here. As an example for image, I am using Digital Elevation Model from NASA. NASA DEM is an improved version of original SRTM DEM. Here, you can also find the description of your dataset. Under band section, you can find actual data that your dataset holds. Here, you can also find the resolution of your dataset, and you can find the name of a band, their minimum and maximum value, and the unit. For some bands, it also tells which value represents which features, as done for water body data here. Under terms of use, you may find a statement that may or may not restrict the usage of dataset. Whenever you use this dataset, you need to cite as such. When you click on import, the dataset is imported in the code editor. Here you can see the image that shows the DEM is an image. Now let's upload a save file for our region of interest. Under assets, you can find new save file option. Here select the save file. When you need to upload save file, you need .sap and some other extensions like .shx, .prj and .dvf. Only .shp will not work in this case. You need all of those extensions together with save file. You can either upload in the zip format. Here in the task, you can see these are the tasks that are running in the background. Now, once you get ticked mark here, your asset has been uploaded in the Google Earth Engine. Now you can view asset and see this is the save file you have uploaded in the Earth Engine. When you click in the import, now this is imported in the code editor. Save file is uploaded as table in Google Earth Engine because the data are stored in tabular structure in save file as attribute table. When you click on the table name here, you may find the description of your save file. To avoid confusion, you may also rename both your image and table As common in JavaScript, we start with var for every code in GE. Here, we are clipping DEM to our region of interest, that is Berlin. Clip function cuts the image so it only covers the area of interest you specify, in this case Berlin. You can click on run here or use keyboard shortcut which is Ctrl plus Enter for Windows and Command plus Enter for Mac. For satellite images having multiple bands, you need to specify which bands you want to correspond to RGB channels for visualization, but in case of DEM, the bands are not the representation of wavelengths or colors, but they hold a unique value of each feature. To select bands, we will use select function. Because we are interested in terrain height, we will use elevation band here. You can get confused with the same names. You can always choose unique name, but here this DEM Berlin is the DEM Berlin, the prior one with only elevation bands selected, so that whenever I use name DEM Berlin, then the Berlin DEM with elevation bands will be used for further processing. I am showing the example of an elevation band, but you are always free to choose which band you want to visualize. You can always refer to the image here to know which bands exist. Now, let's add this DEM as a layer to our map. You can use double slash to make a comment here because it will not be used as a code in Java. Now, let's add our layer in the map. First, let's zoom into the area of interest so that we don't need to locate our map manually, but the map will be zoomed to our region of interest by using map.centerObject function. I am setting a zoom level of 6 so that the region of interest is zoomed in my map. As you can see, Berlin is in the center of my map and also zoomed. Now let's add DEM as layer using map.addLayer function. These are some basic functions which after multiple use you will remember, but there is always docs tab for your reference. In the add layer function, you need to define the image you want to visualize as a layer. You need to also mention minimum and maximum value which you want to visualize. Here you can put it randomly, which you can change afterwards. You need to define palette, the color option you want your layer to appear in. Here, the order of color you put in the palette option is the one representing the minimum to maximum value. Here, brown represents the minimum, whereas red represents the maximum value. You can also give name to your layer. Here, I give the name DEM. As you can see, my layer is added in the map, but it appears brown because the minimum and maximum value I have put is random and this doesn't represent the elevation of my area. If you click on the layer name, a small panel like this appears where you can either change the value range of minimum and maximum value manually or choose the stretch to adjust the contrast automatically. It's important to understand that the minimum and maximum values and stretch options you can see in the map layer panel are only for visualization. They do not change your actual data or represent the true minimum and maximum values in your dataset. As I said earlier, with Inspector tool, you can find the pixel value. Here, I am demonstrating how it works. When you click on the inspector and click on the pixel, any pixel in your layer, then descriptions like this appear. Here it shows this is the DEM, an image, and the value of elevation of the pixel you have clicked on. You can see the value of elevation is higher than the maximum value of the range that we have used for the visualization. This is to show that any values in the visualization parameter is only for visualization and not your actual value. You can actually print your minimum and maximum value corresponding to a dataset. Here, let's find out the minimum and maximum value using the reducer function. When we use image.reduceRegion function, then it will summarize the pixel values over a region, in this case a pixel value or an elevation value of our DEM. Then we will use reducer.minmax function that calculates both minimum and maximum value at once. When we define geometry, the reducer will only consider pixels inside our geometry, and all the pixels outside the geometry are ignored while processing. Scale here represents the resolution of computation. We will match it with the resolution of our dataset to keep it less complicated. When you print the stars, then the result will appear in the console tab. Here, once you run print stars, then you can see the result in the console. We have computed both minimum and maximum value together, and this is what here appear as object property. Here you can see the minimum value of elevation and maximum value of elevation for our DEM. Once you know your values, you can always rewrite the value range in the add layer function so that the layer appears more realistic. Now let's export this DEM as TIFF format into our drive. We will use export.image.toDrive function to export our image in the drive. While exporting image from Google Earth Engine to our drive, there are some compulsory parameters that we need to fill, otherwise the export may fail. We need to define image. Image here corresponds to an image we want to export, which is DEM in our case. We need to also define description. Description is the name given to an export task to Google Earth Engine, which appears in the task tab. Here I give the name DEM Berlin to make it simple. Folder is completely optional. Here, if you write the folder, a new folder will be created in the drive where your image will be exported. Another important variable while exporting image is scale. Scale represents the resolution of image that is being exported. You can either match the scale with native resolution of your dataset or downscale and upscale it. The region is also a compulsory parameter that defines the geometry of your area of interest. The default CRS of Google Earth Engine is WGS84. If you want your image in any other coordinate system, then you should mention CRS here or while running the task. I am using WGS84 but mentioning here just to give you an example. When you run the code in the task tab, you can see export as unsubmitted task. You need to run this to initiate the export process. You can also change the parameters here. Once you run, the task will be initiated. The export process may take some time. You need to be patient. The blue color means that your task is successful, while if there is an error, the color will be red. When you click on Open in Drive, this will locate your image in your drive. You can download it from your drive and visualize it. For some raster files, you may have to visualize in QGIS to have a detailed look. Now, let's work with image collection. We will be working with land cover data from ESA. As done before, we will search for the dataset here. There are two versions. I will choose the version 200, which is for year 2021. You can find the description of your dataset here. It has only one classification band with class values because it is not raw imagery but already processed land cover product. You should take care of the terms of use and citations while using the dataset. You should find save file you previously uploaded in the asset here, but for some reason it is not here. I will get it from the completed task. Let's repeat the same process to add our region of interest in Google Earth Engine code editor. There are multiple functions that will not work in image collection directly. As such is clip function. So you cannot clip land cover to your region of interest directly here. So we need to select an image from image collection first in order to process further. We will filter by date to keep image from particular date in the collection. You can either choose only a single date or two dates for start and end. First function selects the first image in the list. If you are working with any other datasets with numerical value, then you can choose mean or median instead of first. This will give you an image with mean values of all the images based on your filter date. You print the land cover, then in the result you can see image as type. You have successfully selected image from image collection. Now we will repeat the similar process as we did earlier. First, let's clip this image to our region of interest. I want to rename table as Berlin so that I don't get confused afterwards. I am using clip function to clip this land cover map to my region of interest, which is Berlin. Because there are many pixel values that we need to identify in land cover data, so we will describe a palette beforehand. We can choose colors according to the class. For example, green for forest, or red for built up, and blue for water. The order will be from minimum to maximum value. So make sure you know the order of class, or we can always refer from dataset so that the color we choose matches with the class. You can either write color names directly like red, blue or green, or you can use hex codes, which is a 6-digit combination of number and alphabet for different colors. If you want ready-made scientific color schemes, a great source is colorbrewer.org. If you are confused about which color to use, you can refer to the ESA dataset. ESA already provides the official colors for each class. Under band, you can find the class values and color value here. As described, you can either write the name of the color you can see or directly copy the value of color and paste in the code editor to add them to the palette parameter in our visualization. Now let's add layer to our map using map.addLayer function. The image you are visualizing here is Berlin land cover. That's what we will mention here. For minimum and maximum value, you know the range of class which you will be writing here. For now, I am writing minimum at 0 to show what difference it will make in the visualization. You can describe the color palettes here as we did in DEM, but because there are many colors, do not get confused. It is good to describe palette beforehand. Because I put 0 as minimum value, now the forest takes the another color, which is the color described as second in my palette. So when I change the minimum value to 10, then the color matches with the class. You can change the opacity of layer from this slider. You can always check if your land cover map matches the Google map here by adjusting the transparency. We will now export this image to our drive using export.image.toDrive function as we did earlier. You must not miss describing the compulsory parameters, whereas there are some optional parameters which you can avoid or you can add according to your requirement. While exporting an image from Google Earth Engine, you might sometimes get an error saying too many pixels. That's because by default, Earth Engine only allows you to export up to 100 million pixels. But you can increase this limit by adding maximum pixels, max pixels, and corresponding value of 1E13, which means 1 into 10 to the power 13. Then you can export up to 10 trillion pixels. So if your export fails because of too many pixels, just add max pixels and 1E13 to your export settings and it will work. My land cover map is now exported. Here we can visualize after downloading from Google Drive. This is how it looks. Thank you for watching. I hope you have gained some ideas about Google Earth Engine. You are always free to explore examples under scripts. Try with different datasets for a practice. In my next video, we will be learning about Cursor AI, which is an AI-based tool that makes coding easier. This will be for the beginners who are new to the coding. Subscribe and leave the comment in the comment section below.